Hello friends, welcome to Murli Software Tutorials. Hope you are doing better in difficult situation of COVID-19. Murli Software Tutorials since its inception in February 2020, I could able to make 5 to 6 videos, and the response of people is overwhelming. I could able to get 170 subscribers for me, both from both India and overseas, and more than 3000, nearly 3800 views of 201 hours. Yeah, uh, these stats motivates to me do many more videos and help the help the people in learning things. uh, in this session I will going to make tutorial on augmented design, which is a statistical experimental design, which is extensively used in agriculture by plant breeders. Very literary meaning of augment is to add something or to make it larger. To give you an I mean example, like someone want to add extra income through their second job. That's all. You augment. I mean to add something. This is a literary meaning of augment. So before going to the topic, let me give. Let us assume two situations. So you have limited quantity of seeds available with you, because you may get seeds for the first time from a country or person where you don't have enough seeds to replicate them. And second situation will be whenever there's a situation that you have to handle large number of genotypes, say in hundreds to thousands. In that situation, in order to make replicated trials, you don't have any much space and problem of soil heterogeneity, so you can't really control soil heterogeneity, which is essential for conducting the experiment. So under these two situations you can't go for replicated trials. So when you can't go for replicated trials, so you can't estimate error mss. If you can't estimate error ms, it's very difficult to go for test significance and further statistical analysis. So in order to cater these two needs, augmented designs were proposed by Federer in 1956, where you can handle large number of genotypes and with limited quantity of seeds. So he proposed three designs actually: augmented completely randomized design, which is called as augmented design 1, and second one is augmented randomized completely block design, augmented design 2, augmented Latin square design, which is also called as augmented design third. However, augmented design 1 and 2 are generally used in experiments. Among these two, second one, augmented randomized complete block design, is generally used in day to day. All this information and statistical analysis step by step is available with statistical and biometrical techniques in plant breeding by Jawahar Sharma. For the more information, you can go to this book, and you can read further. So let me give some overview about augmented design 2, how this design is actually, I mean, what are all we going to do, what we're going to do in this design. First, what we'll do, the whole experimental field will be divided into B blocks. uh, B blocks means number of blocks. It is designated as small b, and randomization is done in such a way that all the checks and part of the genotype in each block. See, what we'll do, divide whole experimental area into number of blocks, say n number of blocks, or b in this case. So what we'll do, you will place all the checks, and part of the test genotypes will be placed in each block. So how actually we do, let us assume an example here. You have 8 varieties, say variety 1 to variety 8, and you have checks, 4 checks, C1 to C4, and you have designated 3 blocks in your whole experimental area, and E represents uh, checks plus varieties, and total there will be number of plots required, so is 20. So what we'll do here, how the randomization is done, what we'll do, see, you placed all the checks C2, C4, C1, C3 and 3 varieties. So what we did here, part of the test genotypes V8, V1, V4 are the part of the test genotypes among 8 genotypes here, but what we did is we replicated all the checks in B1, B2, B3. So this is how you have to do randomization, and this is how you will conduct the experiment in augmented design. Generally there are tools available, online tools available, you can go and make randomization, or what generally people will do, people will show the test genotypes, and at the end they will place all the checks in all the blocks. So that way also, that is generally followed, or you can do randomization and you can also follow that. See here, your all 8 varieties are placed in 3 different blocks and checks are repeated in each block, so hence there will be number of plots will be 20. So this is the overall skeleton of ANOVA, of augmented design, where source of variation is partitioned into blocks, entries and checks, varieties, checks versus varieties and error. This is the overall skeleton of your augmented design 1. See here, blocks, we made 3 blocks based on our previous example I had given in the last slide. See, we made into 3 blocks, so degrees of freedom will be 2, b minus 1, and entries including both checks and varieties, that is 11. So checks is, there are 4 checks, so 3, varieties, there are 8 varieties, 7, and for checks versus varieties it will be 1. Error will be checks minus 1 and blocks, block minus 1, it will be 6, and total will be n minus 1, 19. And here what they will do, block effects will be calculated to make adjusted treatment, means because here we don't have because we didn't replicated our treatments, I mean like varieties, we only replicated checks but we didn't replicated any treatments, so block effects will be calculated, and it will be deleted, it will be deleted in the treatment means of varieties, and adjusted means will be given. So this is the overall skeleton of ANOVA of augmented design 2. So this is the ANOVA result. See here, what we got is blocks, and you have to see MSS, you can see here, here we blocks, MSS is there, entries, checks, varieties, checks versus varieties, errors. So you can, what is the inference we can draw from this result is mean sum of square due to blocks, entries, checks, varieties and checks versus were significant. It indicates checks were significant among them and varieties also significant, I mean whatever genotypes we used also significant among themselves. What it indicates means there is a significant variability exists present in the experimental material. And there are few points to make better utility of this design. What generally is said that the number of test genotypes may be kept in the each block, same in the each block. In our experiment you can see here what we did is in the block 1 we have 3 test genotypes, however in block 2 we have only 2, and in block 3 we have 3. So what generally it suggested is, so you have to keep same number of treatment, means same number of test genotypes in each block, say 10 each. However this is not a, this doesn't pose any problem while doing analysis in R. I tested, because if you have different I mean differ if blocks differed in number of test genotypes also, it will give output. There is no problem, but it is generally suggested to have a same number of test genotypes in each block. And homogeneity of soil in block can be maintained by increasing the number of blocks and reducing the plot size. And the choices genotypes are re-evaluated in RPD for intensive investigation. So it is just for preliminary evaluation of genotypes. This is augmented design when we have a large number of genotypes. So when you found that if you will identify superior genotypes based on the mean performance of them in augmented design, and later use these best genotypes in RPD in the replicated data. So this is the some introductory part of augmented design. So let me get into the how to prepare sample data for augmented design analysis. What is the MS Excel structure of this augmented design 2? Hope you can see this Excel file here. See, you have suppose 100 entries, 100 your test genotypes, and you have 4 checks, and number of blocks is 4, and I have 2 number of triads, triad 1 and triad 2. So how exactly we arrange the data for analysis? So in the first row or in the first column, what I designated for block in the small blk, or you can give it caps, no problem. And here for the genotypes or entries, I given as TRT, treatments. It is triad 1 and triad 2. And in the first column we add, like first we have to designate number of blocks, block number. See, this is the block 1 and this is block 2, this is block 3. What actually I did here is, in each block I kept 4 checks plus 25 test genotypes. Okay, so there will be 29 genotypes in each blocks. You can see here I have highlighted the checks values in green color, 1 2 3 4, followed by your test genotypes number will start. So 25 your test genotypes and 4 checks, it constitute to 29 in first block. See, first block ends at 29. Similarly, in the second block I placed the check variety data, and genotype, test genotype, there will be 25 number only, but what we have to do is you have to continue the test genotype number from the previous block. See, it's ended at 29, so it has to start with 30. So 30 to 25 means it will end up at 54. Similarly, I have again repeated in third block checks values, and it starts with 55. Similarly, at the end you have to, this number must end up with test genotypes plus checks. See, here we have 4 checks and plus 100 genotype is equal to 104. So if you end up with this number, checks plus test genotypes number, though you correctly did randomization, or you correctly organized the data. Hope there is no doubt here, and I made it clear. So this is how sample data is prepared for analysis. So Let us get into the analysis part. Here I'm going to use augmented design for in order to analyze augmented design. I'm going to do it in R. Actually I wanted to give it, make it in OPStat, because it is easily graphical interface version. Unfortunately that is, sometimes it opens, sometimes it doesn't, so I wanted to make it in R. So first I would like to give some introduction. Before getting into the R, you have to have some preliminary knowledge how to import data, how to install packages, and how to install R and R Studio originally. So what I'm going to do here, first I would like to give some which package we need to be used for augmented design analysis. See, in the if you don't have one such package in the install, you can go here, you can type augmented. See, this design can be installed, augmented RCBD. I have already installed here augmented RCBD. This design, I mean this package you can use for analysis. So I will put on this one. You can see that is loaded in my console. And now what I'm going to do here, I'm going to import the data set from Excel. So I'm going to browse, and it is present in education analysis tutorials. In the augmented design, in the sample augmented data, we are I'm going to take it from sheet 2 because in the example file, uh, uh, just wanted to show you because why I took it from sheet 2, because this is in the sheet 2 I have similar data of sheet 1, but because of I made some modifications here. See, I have entered some other data, and so I wanted to take clean data, so I just took it from sheet 2. You can see here sample augmented data has been loaded in the R. There are 116 observations of 4 variables. Okay, 116, how it will become 116? Because you have 100 genotypes, and 4 into 4 checks are repeated 4 times. There are ends for each variable, there will be 116 observation. However, block or treatment are not variables, but it considers like that. But treatment 1 and triad 1 and triad 2 are the our data to be analyzed. So here in the augmented design, this design we are going to use is augmented RCBD bulk, because at one go we will analyze the data. You can also analyze your data, I mean like single trait only, and there is option to be analyze data simultaneously. So I will show you how to do data analysis simultaneously if you have more than 2 traits, or if you wish you can do with augmented RCBD using this one. If you have only one trait, you can do with this one, analysis of augmented randomized block design. Or because I have 2 traits, I will go with augmented bulk. This also works with single trait. I suggest you to use this one, it is very easy. So here we have data, you can see here 116 observations and 4 variables. So let me tell you how to write script for this. So here first you have to define in R which is your data frame. So what I'm going to do here, so I will tell R that AUG, this is my new data set. So okay, I will show you in new this one. Okay, I will yeah, see what I'm going to do here is AUG, this is my new data set. Use equals this symbol, and data frame. So you have to define data, which data frame, this one, sample data, this one. See, what I am telling to or is that AUZ, new data frame, is the data I imported into the R. So you select this one and run. Okay, so you can see here data, our new data set is created in the in this I mean like in this tab. So next what we have to do is this step we already see here, block treatment y1 y2, we have here example data. So we already we are at this data frame, we already defined data f is there, no? So data f here is similar to our AUZ. So we already defined what is our data, what is the block in that data, what is treatment in data, and y1 and y2 means triad 1 and triad. This is the triads to be analyzed. So we already defined our data frame. So next is analysis. So this is the code for analysis. So what I'm going to do here, I will place here you have to define what is your data. Our data is augmented, and what we given for block, you just see here we given BLK for block and TRT for treatment. That is what we have to indicate here. See, block and TRT. Okay, so next what I'm going to do here, you have to define what are the triads you are going to analyze. So first one is I have triad 1 in triad 2. Okay, fine. So checks need to be kept null and alpha, that is at 5% level of significance, and describe is true, frequency distribution true, GVA means genetic this is GV analysis like GCV, PCV, heritability, genetic advance, all going to will be calculated. And checks colors you have to define here. See, since we have only 4 checks here, brown, dark cyan, forest green, purple, these will come up in our in graphs in histograms they will come. So each check will be indicated with different color. Since we have 4 checks here, so we have to indicate with 4 colors. Okay, so next, so we have defined what is our data set here, what are all the triads, what is the block in our data set, what is the treatment in our data set, and also we defined color for our checks. So then we can go for run. See, because error came up because I wrongly defined triad 2. See, what actually I written for triad 2, TRIAT 2, TRI. So these kind of mistakes you should avoid, because any single alphabet mistake will lead you to the error. Let me run again. Okay, it's running, that's good. Okay, so you can see here result came. Okay, our analysis is successful. Okay, triad 1, triad 2 is completed. Number of blocks is 4, number of treatment is 104, number of check treatments are 4, number of test treatments are 100. Okay, and check treatments are 1 2 3 4, number of triads are 2, triad 1 and triad 2. So based on this you assume that our whatever the input is given is correct. So there will be 2 kind of ANOVA. One is treatment adjusted and block adjusted. You can copy directly from here to Excel, but in the few minutes I'm going to teach you how to export the data. So you can also you will also get a coefficient of variation, like for each triad you analyze, and overall adjusted means. You will also get standard error to make comparison. You also get critical difference. there will be four critical differences here as compared to our replicate data where we'll get only one CD. But here we will have four critical differences, like a test treatment and a control treatment to compare between test and checks, and control treatments to test significance among checks only, and two test treatments, the treatments which are present in different blocks, in order to compare two treatments in different blocks and two test treatments of the same blocks. And there will be four different CDs in augmented design. So you will also get descriptive statistics here, like mean, standard deviation, minimum, maximum skewness, and kurtosis, and you will also have genetic variability analysis here. So what we given here, GVA true, that is came here. Genetic variability analysis, like phenotypic variance, genotypic variance, environmental variance, GCV, PCV, and it will also give their category, whether it belongs to high or low. We have categories. If it is more than, if GCV is more than 20, it is high. If it is 10 to 20, it is moderate. Less than 10 is low, like that. So it also give heritability, they also give genetic advance and everything at one go. And you will also get treatment means, adjusted treatment means, by deducting the block effect. So because there is a huge data, I mean huge output, it's difficult to take it from here and copy in Excel. So instead there is we can use here, see, in the augmented design, let me show. You can see here, this is report date augmented bulk. Okay, this is the this is the export, how you need to export your output. So how we have to do, here is the code report. I copied from here, but I made some changes, so I will copy this one. So paste here. Okay, what I'm going to do here, about, you have to define your output file name and you have to define your file path. Okay, so I'm going to define my file path to my desktop, and this is the name, augmented date. Okay, I will change it as sample augment. Okay, whatever the name you wish, you can give. So I will going to run this one. Wait till stops goes. It's better to wait till red goes. Okay, we successfully did this, and our file is created at desktop. So let us go to desktop and see what we got. So see here, we got our analysis report here. Let us open in it is in word format, and so let me open this. Okay, see, oh sorry, unfortunately my battery gone low. Let me plug in. Yeah, this is the output here, you can see. So it will contain everything, whatever the information we saw in our console. See, okay, here is the ANOVA. Okay, right, this is treatment adjusted, and it is block adjusted, and you can have standard errors, you can have critical difference, you can have CV overall adjusted means. We will have for each statistics, descriptive statistics, and you can see, as I told, each check will be highlighted with a different color, and you will get these means graphs for whatever the trait you are going to analyze. And you have okay, in order to see this we have to go layout, change the layout, landscape. Okay, now see, yeah, let me make it this one smaller width. Okay, fine. Yeah, So we have genetic variability analysis here at one go. So this is the overall output. So let me change again portrait mode. So yeah, how to make a table out of this? Yeah, let me open. I will show. Actually, there is no need to do anything much here because it's already given in a readily table format. So this is ANOVA for us. Control C I'm going to do here. For this one. Okay. And I want to take this is source. So one is treatment adjusted, one is block adjusted, but we are interested in to check whether there I will highlight some of the things will be common in both, like this one you can see checks. Okay, let me highlight with, you can see these will be same and the residuals will be same also. Yeah, sorry. Okay, you can see residuals also same. Fine. Okay. Yeah, so generally I'm going to consider uh, there is no hard and fast rule that which one you need to keep. Generally what I'm going to do is because these two are common, I'm going to keep one of them, and I used to keep all of these. um, uh, what actually we are interested is whether let me show here. See, we have four checks. It means four checks and minus one of degree of freedom, so that we'll get three checks. And our treatment, our see, our checks are significantly different among them. So for both try 1 and try 2, this is for us. And whether test versus checks. Okay, so whether our treatments are significantly different from checks used. Yes, because our MSS is significant. Yeah, so this is what important for us. And whether our treatments are what are the entries. See, we have 100, so n minus of 1 will be give you like 99. Fine. Okay, n minus 100 minus 1 will be 99. See, our treatments also, I mean our test genotypes also significant. And very interestingly, block, you can see here block eliminating treatments. Okay, blocks also non-significant. It may indicate our soil is homogeneous for fertility things. So this is what important for us. If you want, you can keep these things also by removing the common ones. So like how, see, yeah, I'm going to delete this one. And this is also common. Let me delete. This is common. Yeah, final, maybe you may keep like this, or you can keep this one only. uh, this one, this will the which is highlighted with colors will suffice your requirements. So you wanted to just to know whether checks are differ or not, or whether in comparison to text our test genotypes are different or not, whether our test genotype itself showing variation, is there variation or not through test of significance. So I think this ANOVA will do things for you. So other than this one, See, this is it, this output is readily use output. You can just copy the things and do it, and you can use these CD values in order to find out the best genotypes. And you may use like maybe you can use uh, based on your requirement. If you want to compare the control treatment, means you can use this one. If you want to use a control treatment and test genotype, you can use this one. And if you want to compare two test treatments, you can use this one. And within the block you want to compare, you can use uh, this two testaments of same block. So it's all depends on you. And coefficient of variance, coefficient of variance is indicate what is the variability in your experiment material. So it is within the limits, like generally it is expected to have at 5 to 20. Actually there is no hard and fast rule that CV should be this much, but generally it is assumed that it should be 5 to 20. This is fine. And other than this one, descriptive statistics is available. If you wish, you can use this one. And very importantly, graphs for publications, you just copy them. You just you just copy them and place wherever you want. uh, okay, okay, this is how simple it is. And similarly this one, suppose, actually, let me delete this. Okay, we need this. Fine, delete. Okay, you can, so just copy and let me delete this categories. Yeah, this is great. Yeah, yeah, genetic variability analysis, just control C, and that's something I can solve. Okay, right. Control C and go here. Sorry. Yeah, control M. Okay, this is how simple it is, making tables out of it. Yeah, you see mean is there, GCV is there, PCV is there. See, our heritability is also good at it's on higher side. So this is how you extract from output of the design. So this is what I would like to tell you the people about this one, how to do analysis and all. Okay, I would like to end the session here, and I really thankful to uh, Jawahar Sharma book for providing skeleton of the whole. You can Jawahar Sharma book, which is I mentioned in the earlier, I mean first second slide, I think. You can refer to this that book if you have any doubts. And I would like to also thank R, which is a free source. Anybody can exploit that one if you are interested. And I also thank developers of augmented RCBD package. And I would like also thank OBS Studio, which is allowing me to make these videos. And I would like to say here, with all this explanation, hope you got what augmented design is, and how actually you prepare sample data, and how actually you analyze using R. So still, if you got any doubts, you can contact me using through this mail, murlib5002 at the rate gmail.com, or you can comment me in YouTube my YouTube channel. So I will try to answer best of my abilities. Or you can contact to my WhatsApp number 9844198361. So uh, this is what I would like to tell today. And thanks for your patience, and thanks for encouraging me to do these videos. And hope okay, I will come up with new videos in the future. Thank you, thank you, one and all.